Hello everyone, I hope everyone is doing well. In this video, we will discuss beams, different types of support and different types of reaction. So first of all, let us discuss what is beam. Beams are usually long straight bar, right? These long straight bar must have a uniform cross-sectional shape and uniform cross-sectional area. So beams usually they are long straight bar, like you can see here. I have this steel rod with me, so it is uniform, and the cross-sectional area here you can see this is uniform throughout the beam, and it is a long straight rod. Now this straight rod or straight bar, if this is supported horizontally, usually the beams are supported in a horizontal position, like in this position. So this is a long straight bar, it is supported horizontally, and this will have to carry vertical load. So these few are the main points of the beam. It will be a long straight bar having uniform cross-sectional area, having uniform cross-sectional shape. It will be supported horizontally and it will carry vertical load. Now, how we support the beam, we use different types of support. What are those support? So if we have, let's say this is that long straight bar, so how we support it, right? If I have this bar, how I support it? So we use different types of support. The first one is pin support here. You see this one, it is known as pin support. If it is supported like this, not the whole beam, this end of the beam I am talking. We can support the beam with the help of roller support. If I put a roller here and put the beams on it like this, it will be a roller support. So this support is known as roller support. And if I fix the beam from one end completely like this, you see here, and this is fixed, so this is known as fixed support. So these three different types of supports we will be using in our videos throughout the course. Now, based on where we support the beam, we have divided the beams into different types. So if I have pin support, you can see here all these images. In the first one, you can see here, I have pin support on the left side and I have roller support on the right side. And the beam is just simply placed on the roller support. So it is simply supported beam. This one, the first one is simply supported beam. Now, in number 2, you can see here, if I just bring the roller support to the middle of the beam, so what will happen? Some region of the beam will be overhanging over the support. So, and the other end is same, like we have the pin support. So this type of beam, we call it overhanging beam. Overhanging beam. The third type is if I have a beam which is fixed from one end. You can see here, if I have this beam, it is fixed from here and free at the other end. This is known as cantilever beam. Right? You can see here, this is known as cantilever beam. And if I have a beam and I fixed it from both the end, I fixed it from here and I fixed it from here. So both sides I have fixed support, that is known as fixed ended beam. So you can see in number 4, fixed ended beam, because it is fixed from here and fixed from here as well. The fifth one, we have continuous beam. Continuous beam is a beam which has pin support here, roller support at the other end, same like the simply supported beam, but in the middle we support it with some other support, like here we have roller support, here we have roller support. So throughout the beam we have different support. We call it continuous beam. And if we have a beam which is fixed from one end, like here in number 6, and we have a roller support at the other end. So if we have a roller support, just simply support it from there. So, but the other side is not pin support, it is fixed support. So that type of beam is cantilever simply supported, because it is fixed from here. So the cantilever is coming from here when it is fixed from one end, and at the other end it is simply supported just with the help of roller support. So this is known as the cantilever simply supported beam. Now, as we discussed, that these beams will carry vertical load. So what are the possible types of load which these beams can carry? We will discuss 3 different types of loading condition. Now the loading condition could be, if I have a beam, this is a beam, right? And if I apply a load here in the center of the beam. So if the beam is acting exactly at one point of the beam, that type of load we call it point load. So we can see here, if the load is acting here, and let's say this force is acting at this point, so this type of load is known as point load, right? This is point load. It can be here on the cantilever beam like this, in the fixed ended like this, anywhere on any beam. This is known as point load. Now we can also have a load which is not exactly acting at one point. It is not concentrated at that one point. It is distributed to some region of the beam. Like if we have this region of the beam and I have a load from here to here. So I will show it like this. So this load is uniformly distributed on some region of the beam. So we call it uniformly distributed load. So uniformly distributed load is a load which is distributed over some region of the beam. Sometimes when we are considering the load, the weight of the beam itself is a load, so we consider that one as uniformly distributed, because the weight of the beam is uniformly distributed throughout the length of the beam. So this is another type, we usually call it simply UDL, uniformly distributed load. The other type of load which we will discuss in this course could be axial load. It is same like point load, but point load is acting straight perpendicular to the axis of the beam. If I have this is the axis of the beam, so the point load is acting straight perpendicular. But if I have the same point load, but it is acting at some other angle. If I have this load and it is acting at an angle like 45 degree, let's say, not 90 degree, so then this is axial load. It could be like here, it could be like here, let's say this is 60 or 80 degree, whatever degree other than 90. So that type of load is known as axial load. So with this load, then what we do, later on we will discuss, usually we have to resolve into its component and find the vertical component and horizontal component. Now when we have the beam, we have different types of support, and if you apply load to the beam, so what will happen to the support? From the support we will have reaction forces, because the load itself is acting as an action, so we will have reaction from the support. Now what are the possible types of reaction on different support? If we have a pin support, keep this thing in mind. When we have a support and if I try to move the beam having that support fixed at that point, so if I can move the beam in any of the direction, it means there will be no reaction. Like if I have this beam and I have this roller support, if I can move the beam in this direction, so means there is no opposition, there will be no reaction. But if I am not able to move the beam in this direction, it means there will be some reaction force from that side. So this is the easy way to find how many reaction will be on each support. So the pin support here, you see here, this is the pin support. In this pin support, we can rotate the beam in this direction. We can rotate clockwise or anti-clockwise. So if I can rotate, I don't have any moment as a reaction. But if I try to move the beam in this direction, I cannot move. If I try to move the beam up, down in this direction, I cannot move. So it means there are two possible reaction forces on this support, which is, let's say this point is A. So I will have a reaction force AY in the upward direction, and I will have a reaction force AX in the horizontal direction. Now why I am keeping the direction upward and to the rightward, it depends on the sign convention, but later on in problem solving we will discuss it in detail. Now I have this roller support. So if you look into the roller support, I can rotate it easily. At the same time, I can move this in the horizontal direction. So means there is no moment as a reaction. There is no horizontal reaction force because I am able to move the beam in the horizontal direction. And if I try to move up and down, I cannot. So mean there is only one reaction force, which will be AY. In the upward direction, we will have a reaction force. The third one is fixed support. So in the fixed support, if I try to move the beam in upward direction, I cannot move. So it means there will be a reaction in the Y direction. If I try to move the beam in horizontal direction, I cannot move. So it means there will be a reaction in the horizontal here and in vertical here. And if I try to rotate the beam, I am not able to rotate because it is fixed. So it means there will be moment as a reaction here. In all other support, if I try to rotate, I can easily rotate the beam. So meaning there is no opposition, no reaction force. But here in this case, I am not able to move. So I can easily, I cannot easily move rotate this in the clockwise or anti-clockwise direction. So I will have moment as a reaction force. So on pin support, we have two reaction forces, horizontal and vertical direction. On roller support, we have one reaction force in the vertical direction, and on fixed support, we have three reactions, which is the two are the forces, horizontal and vertical direction, and one is moment, which might be clockwise, anti-clockwise. Later on, we will discuss this. Now, to find the reaction forces on different types of beam, like we have the fixed simply supported beam, we have the overhanging beam, the fixed ended beam, continuous beam, and cantilever simply supported beam. In the coming videos, we will be solving example how to find the reaction forces due to different loading conditions.